Dr. Adeline Shiba, Professor, Department of Computer Science and Engineering, St. Joseph's Institute of Technology, Chennai. In this section, we are going to see about NumPy. NumPy stands for Numerical Python. It is an open source Python library. It facilitates so many mathematical functions. So now we are going to see the functions in NumPy. So the first thing we are going to see is the arithmetic operators and the arithmetic functions. So already we have the concept of operators. So we can perform all the operations with the operators. So apart from this, we have the arithmetic functions. So these arithmetic functions, we call it as U functions or universal functions. So now we want to know what is the advantage of using these U functions. So actually, U functions are faster and it is mainly used for n-dimensional array. So it supports array broadcasting, typecasting, and also it has so many features. So it is better to use U functions because of the speed. Okay. So the arithmetic operators available are addition, subtraction, multiplication, division, power, and modulus. For this, we have the corresponding U functions. So the U functions are add, subtract, multiply, divide, power, and modulus. So now we are going to see example for each of these U functions. So the first thing we are going to see is addition. So to perform this, first we have to import the NumPy library. So for this, we have to use the command import NumPy as NP I am giving. Okay. Now I am going to create an array. So for this, I am giving x equal to NP. I am using this NP dot array of. So any array I am creating. So 1, 2, 3, 4. And then I am creating one more array. Y equal to NP dot array of 5, 6, 7, 8. So now we have to perform addition operation. So I am having a variable result1 which is equal to x plus y. Then I am printing the value print of result1. Okay. Now let us see the output. The output is we are going to perform element by element addition. So, okay, so here we have 1 and here we have 5. So 1 plus 5 is 6. Then 2 plus 6 is 8. 3 plus 7 is 10. And 4 plus 8 is 12. So this is the output we have here. Okay. So the same thing we can perform using U functions also. So for this, I am going to consider the same example. Okay. So here only I am going to make the change. So result 1 equal to NP dot add of x comma y. We have to use like this. Then I am printing the result. Okay. So we will be getting the same output. So this is an example for addition. So in the same way, we can perform subtraction also. Now we are going to perform subtraction. So we are going to consider the same example. So for subtraction, instead of plus, I am giving here minus. Instead of plus, I am giving here minus. Okay. So the output will differ now. So here it is 1, minus 5 is minus 4, and 2 minus 6 is minus 4. 3 minus 7 is minus 4 and 4 minus 8 is minus 4. So this is the output. Okay. So for this we have the corresponding U function. So the U function is NP dot subtract of. The U function is NP dot subtract of x comma y. So if we print that one, we will be getting the same output. So now we have completed subtraction. And the third arithmetic operation we are going to see is multiplication. So for multiplication, again we are going to consider the same example. So here instead of minus, we have the multiplication symbol into, and then I am trying to print it. Now it will do element wise multiplication. So now the output is 1 into 5 is 5, 2 into 6 is 12, 3 into 7 is 21, and 4 into 8 is 32. So this is the output. So for this we have a corresponding u function. So instead of subtract, we are using multiply. Instead of subtract, we are using multiply, and we will be getting the same output. So now we have completed addition, subtraction, multiplication. Now let us go for division. So here we are using the division symbol. Let us consider some other example. Okay. So the first array I am having is 6, 8, 10, 12. Okay. So the second array we are having is 3, 4, 5, 6. Now let us divide x by y. So the output will be 6 by 3 is 2, 8 by 4 is 2, 10 by 5 is 2, and 12 by 6 is 2. Okay. So actually in output you will be having 2 point. So the reason is, while dividing we may get 0.25 or we may get 0.3. So for this purpose it's coming as a floating point number. Okay. So the same thing, we have a corresponding u function in NumPy. So the u function we have here is divide. The u function we have here is divide. Divide of x comma y, and if we print the result we will be getting the same output. And the next arithmetic operator we have is power. So we can take an example for power. So here also we are creating two NumPy arrays. Okay. So the first one we are having it as 5, 4, 3, 2. Okay. And then here the second array we are considering it as 1, 2, 1, 3. Okay. So now we are going to perform the power operation. So we are using the power symbol. And we are printing. So the output is 5 power 1 is 5, and 4 power 2 is 16, 3 power 1 is 3, and 2 power 3 is 8. So this is the output of this, and here we have the power function. So we are writing np dot power of x comma y. We will be getting the same output. The last one we are going to see is modulus. Okay. So modulus is nothing, it will give the remainder. Okay. So let us take an example. Okay. So here we are using the modulus operator. So let us see the output here. Okay. 5 modulus 1, it is 0. 4 modulus 2, it is 0. Okay. 3 modulus 1 is 0, and 4 modulus 3 is 1. Okay, this is the remainder we have, and we have a corresponding u function in NumPy. So here we are going to use modulus. Now we are going to see NumPy comparison operators and functions. So here we have the operators less than or equal to, greater than or equal to, and not equal to. So for this we have the corresponding comparison functions: less underscore equal, greater underscore equal, and not equal. So for this let us see example one by one. First let us see example for less than operator. Okay. So first we have to import NumPy. So we are importing NumPy as NP. So now we are going to create two arrays for comparison. The first one is x equal to np dot array of 1, 2, 3. And second one we have is y equal to np dot array of 3, 2, 1. So now we are going to compare. So I am having a new variable result 1 which is equal to x less than y. Okay. As we are going to perform the less than comparison, I have written x less than y and then I am printing the result. Okay. So before seeing the result output, let us see the corresponding u function in NumPy. So the corresponding u function in NumPy is less than. So we are going to take the same example. Here I am going to write result 1 equal to np dot less of x comma y. Then I am printing the result. So now we are going to see the output. As I have told you, u functions perform element by element comparison in an array. So now we are going to perform element by element comparison. So here we are comparing 1 and 3. So 1 less than 3, yes. So it is true. And second one, 2 less than 2, it is false. And then we are comparing the third element, 3 less than 1, it is also false. So this is the output. So now let us see the second function, less than or equal to. So okay. So here instead of less than, we are writing less than or equal to. Okay. So here we are writing less underscore equal of x comma y. Okay. So the now output differs. Again we are performing element by element comparison. So 1 less than or equal to 3, yes, it's true. And 2 is equal to 2. So now the second one is also true. Now 3 is less than or equal to 1. No, it is false. So this is the output we have. And the third one we have is greater than. Okay. So now instead of using less than or equal to, here I am putting the greater than symbol. And here for this corresponding u function, we are taking np dot greater of x comma y. Okay. So now let us see the output for this. Again we are performing element by element comparison. 1 is greater than 3. No, it is false. So here I am writing it as false. And then 2 greater than 2, no, it is equal. So again it is false. And third one, 3 greater than 1, yes, it is true. So here we have the output true. So now we have completed the greater than operation, and next one we have is greater than or equal. Greater than or equal. So instead of greater than symbol, we are writing here greater than or equal to y. So here we have the corresponding function, u function, greater equal of x comma y. So now let us see the output for this. Again element by element comparison. 1 greater than or equal to 3, it is false. And 2 is greater than or equal to 2, now it is satisfying the equal to condition. So it is true. And the next one is 3 greater than or equal to 1, yes, it is true. So again we have true. So this is the output. The next function we have is equal. So here we have to use the double equal to symbol. Okay. Already we have the equal to symbol for assignment. So for equal we are using the double equal to symbol. So for this, we have the corresponding u function np dot equal of x comma y. np dot equal of x comma y. Now let us see the output. So we are comparing 1 and 3. 1 and 3 are not equal. So it is false. And 2 and 2 are equal. So it is true. And 3 and 1 are not equal. So again it is false. Again it is false. So this is the output. And the last comparison operator we are going to see is not equal to. So instead of this one, I am replacing it with not equal to symbol. I am replacing this with not equal to symbol. And we have the corresponding u function here, not underscore equal of x comma y. This is the corresponding u function. So now let us see the output. Okay. So 1 is not equal to 3. Yes, it is true. And then 2 is equal to 2. So it is false. And 3 is not equal to 1. So it is true. Okay. So now we have seen all the comparison u functions. Okay. Totally we have seen 6 comparison u functions. Okay. The beauty of u function is we can perform element by element comparison and it is faster. Now let us move to the next topic. Now we are going to see bitwise operators and functions in NumPy. So as we all know, the bitwise operators are AND, OR, NOT, XOR, left shift and right shift. So for this we have the corresponding u functions in NumPy. So for bitwise AND, bitwise underscore AND, then bitwise underscore OR, bitwise underscore NOT, bitwise underscore XOR, left shift, right shift. So now we can see this one by one. The first one is bitwise AND. So first let us see the truth table for bitwise AND. So for bitwise AND, if both values are 1, the result is 1. If one of the value is 0, the result is 0. And if both values are 0, then also the result is 0. So based on this, we are going to do the program. So now we have to import NumPy as NP. Now I am taking two numbers, integer 1 equal to 9 and integer 2 equal to 8. So now I am going to perform the bitwise AND operation. So result 1 equal to int 1 and int 2. Okay, this is the bitwise AND operator. Then I am printing the result, print of result 1. Okay. So for this we have the equivalent u function. So the equivalent u function is result 1 equal to np dot bitwise AND of bitwise underscore AND of int 1 comma int 2. Then I am printing print of result 1. So now let us see the output. Now let us see the output for this. Okay. So already we know the truth table. If both values are 1, then only the result is 1. Okay. So now we can write this. So first one is the number 9. Okay. So we can write the number 9 in binary. So this is a decimal number. We can write this in binary. Okay. So before that we know. So 2 power 0 is 1. 2 power 1 2. 2 power 2 4. This one 8. So we know the position. Okay. So now the value is 9. So 9 is 8 plus 1. So in these positions we have 1 and in remaining positions we have 0. Okay, and in remaining positions we have 0. So we have written 9 as this one in binary. And then the next number we have is 8. Okay, so 8 we have to write in binary. So here the 8 is in this position. So here we have to put 1. The remaining digits are 0. The remaining digits are 0 in binary. Okay. So now we have to perform bitwise AND operation. So according to bitwise AND operation, if both values are 1, then the output is 1. So here in this the both values are 1, so the output is 1. And in remaining places the output is 0. And in remaining places the output is 0. Okay. So now 1 is equal to 8 in decimal. So the resultant output is 8 in decimal. 8 in decimal. Okay. So the output of this one is 8. The output of this one is 8. Okay. So that is bitwise AND of 9 and 8 is 8. So next we can perform the bitwise OR operation. Bitwise OR. So the symbol for bitwise OR is this one. So I am putting the symbol. Okay, that's the difference here. And we have a U function for bitwise OR. So instead of AND, we have to write bitwise OR of int1 comma int2. Okay. So let us see the truth table of bitwise OR. So bitwise OR truth table is if any one value is 1, the result is 1. Okay. So now if both values are 1, okay, any one value is 1, the result is 1. Okay, 0, 1, the result is 1. 1, 0, the result is 1. But if both values are 0, the result is 0. Okay, if any one value is 1, the result is 1. So this is the truth table for bitwise OR. So based on this, we are going to perform the OR operation. This is the result of the AND operation. Now we are going to perform the OR operation for the same two numbers 9 and 8. Okay. So let us see perform the OR operation. Here one of the value is 1. So the output is 1. Okay. Here also one value is 1. So the output is 1. So the remaining values are 0. The remaining values are 0. Okay. Now if we take on the position, so here we have the value 1, corresponding value is 8, here the corresponding value is 1, so 8 plus 1 is 9, so which is equal to 9 in decimal, which is equal to 9 in decimal. Okay. So the output of bitwise OR is 9. The output of bitwise OR is 9 here. The next operation we have is bitwise NOT. Okay. So for bitwise NOT, only one number is enough. Okay. So here we are not going to calculate anything newly. So we know that for bitwise NOT, okay. So for if n is the integer, okay, if n is the integer, then the output will be minus of n plus 1. Okay. According to bitwise NOT, if n is the integer, okay, the output will be minus of n plus 1. So now for bitwise NOT, okay, we are going to consider only one number, okay, and the symbol for NOT is this symbol, okay. So now we are printing the result, and the corresponding U function here is bitwise underscore NOT of int1. Okay. So now we are going to print the result. Now let us see. Okay. So what is n? N is 9. So here the output is 9 plus 1 is 10. Then we have to put the minus symbol. So the output is minus 10. So this is the calculation. Okay. If n is the number, the output of NOT is minus of n plus 1. So 9 is the number. So n plus 1 is 10. So minus of minus 10. Okay. So we have minus 10 as the answer. So this is the answer for bitwise NOT. Next one we have is bitwise XOR. Next one we have is bitwise XOR. Okay. So again we are going to take the two numbers. For bitwise XOR, the symbol is int 1, this int 2. And we are printing the result. Okay. And here for bitwise XOR, bitwise underscore XOR of int 1 comma int 2. Then we are printing the result here. Okay. So for bitwise XOR, the truth table is if both values are 1, the output is 1. Okay. Both values are 1, the output is 1. Now we are going to see bitwise XOR. Okay. So we are going to consider the same example, integer 1 equal to 9 and integer 2 equal to 8. So for XOR, the symbol is this one. So int 1 XOR int 2, and I am trying to print the result. Okay. So the corresponding function, u function in NumPy is np dot bitwise XOR of int 1 comma int 2. Okay. So for bitwise XOR, okay, if one of the value is 1, then the result is 1. Okay. If one of the value is 1, okay, then the result is 1. So here the result is 1, in remaining places the values are 0. So this is the truth table for bitwise XOR. So based on this we can calculate. Okay. So now we are writing it for XOR. Here in this the one of the value is 1, so here we have 1, but in remaining all places we have 0. Remaining all places we have 0, so we are writing 1, 2, 3, 4. Okay. So this is the thing. So what is the output? Which is equal to 1. Which is equal to 1 in decimal. Equal to 1 in decimal. Then finally we have two more operators. One is left shift and another one is right shift. Okay. So for this we are going to take a different format. Okay. So first let us see what is left shift and what is right shift. Okay. So suppose let us take a number 3. So for this we are going to find the left shift. So okay, so as we all know 1, 2, 4, 8. So okay. So for 3 here in two places we will be having 1 and in remaining places we have 0. Okay. So let us draw like this. The 4 numbers bits are 0, 0, 1, 1. So these are the 4 bits we have. So now we have to shift the bit to the left place. Okay. So we are shifting this 0 here and also we are shifting this 0 here. We have shifted. Okay. So now we are shifting by 2 positions. Okay. Now I am shifting by 2 positions. Okay. So I am shifting this 0 and 0. And I will discard it. Okay. So these two are the discarded bits. I am discarding it. So these two are the discarded bits. Okay. Now this one will come here straight to the 0. This one will come here. Okay. And this one will come straight to this. Okay, but here these two places are empty. These two places are empty. So what we are going to do is we are going to replace this one with 0. We are going to replace this one with 0. So this one we call it as replacement bits. This one we call it as replacement bits. Okay. So now the value is, this one we have discarded, so leave it. So now it is 1, 1, 0, 0. Okay, 1, 1, 0, 0. So 1, 1, 0, 0 is what? This is 8 and this is 4. which is equal to 12. So 12 is the output. Okay, 12 is the output. So now let me tell this. Okay, so we are using the operation of left shift. Okay, so I am going to take one integer int1 equal to 3. Okay, then going to use the left shift operator. So left shift of 3. Okay, so to the position, which one we are going, sorry, left shift of, we are going to left shift integer 1, okay, to 2 position. Okay, so the corresponding function we have here is np dot left underscore shift of, okay, this int1 we are going to shift by 2 positions, okay, by 2 positions, and we are printing. Okay, so what will happen? So the number 3, so we are converting it to binary, it is 0011. Okay, so for understanding I have drawn like this. So we have to shift it to the left side. Okay, so these 2 bits I am shifting it to the left side and I am discarding. Okay, then automatically this bit will come in this position and this bit will come in this position. Okay, as we have 2 shift. Okay, then what we are doing, these 2 places are empty, so we are replacing it with 0. So these bits we call it as replacement bits. Now this one has been discarded, so remaining 1 1 0 0, this is the value. So this is 8 and this is 4, so 8 plus 4 is 12 is the output. So the output for this is 12. Okay, the output for this is 12. And the next one we have is right shift. Okay, the next one we have is right shift. The same example we are going to consider. Okay, instead of left shift we are going to use right shift again by 2 position. Okay, again by 2 position. Okay, so now let us draw this diagram. Okay, the binary value for 3 is 0011. So again the same concept. Okay, 0 0 1 1. Okay, so now we have to shift it to the right side twice. Okay, now we have to shift it to the right side twice. Okay, so this 1 I am shifting here. Okay, and this one also I am shifting here. So I am discarding this 2. Okay, I am discarding this 2. And this 0 will come to this place. Okay, this 0 will come to this place. Okay, and this 0 will come to this place. Okay, so now we have 2 more places. Okay, now we have 2 more places. Both places are empty. So we are introducing this with 0. So this one we call it as replacement bit. Okay, so this one we call it as replacement bit. Replacement bit. Okay, so now you see the value, it is 0 0 0 0 because this 2 we have discarded. So the remaining value is 0 0 0. So the output is 0. Okay, so the output of this is right shift operation. Okay, so we have right underscore shift, the output is 0. The output is 0. So with this we are completing the bitwise operators and the corresponding U functions in NumPy.